So today we're going to learn about the tabular method, which, as it sounds like it, is going to be integration by parts, but in a table. And it's much easier this way in a table, and we're going to show an example of why it's much easier in a table versus the original of Dove. That's what I like to call it. So using our trusty late, also known as logarithmic, inverse trig, algebraic, trig, and exponential, we can figure out that u is going to be x cubed because it's algebraic versus trig, which is farther down. So our dv is sine of x dx. Our du, if we take the derivative of this, is going to be 3x squared, and our v, if we take the antiderivative of this, is going to be negative cosine x, right? So we're going to use our formula of, let me just write it down real quick, uv minus the integral of v times du. So let's plug stuff in. So our u, x cubed, times our v, negative cosine x, minus the integral of v, negative cosine x, times our du, 3x squared. So you're going to notice that this integral you can't do simply like in our previous example we had something like, I think it was x squared. You can do that. There's no products here. But here we're going to have to redo integration by parts again. Okay? And that is going to be no fun. No fun. So instead, let's just get rid of that. Am I right? Okay. Instead, what we're going to do is we're going to set up a table. Right? Okay. So we start off with u, which we've already determined is x cubed, and our dv, which is sine of x. Now here, you don't have to include the dx, okay? So as you go down here, down this table, you're going to keep taking the derivative until it reaches 0, and that's when you stop. So it's going to be derivative. Now here, as you go down, you're going to take the antiderivative. Antiderivative. Okay? So the derivative of x cubed is 3x squared. 3x squared. And our antiderivative of sine of x is negative cosine of x. Are we at 0 yet on this side? No, that means we continue. So 6x and negative sine of x. We're still not at 0, so take the derivative once more. 6 and cosine of x. Keep moving. Now the derivative of 6 is 0, so that's where you stop. You stop taking the derivative, and you stop taking the antiderivative after this one. Sine of x. Alright, so now what we're going to do is we're going to multiply across this, right? Across, across, and across. And each alternating one is going to be a different sign. So this is going to be positive. It always starts off with positive. Then it goes to negative, positive, negative. Okay? So as you multiply these two, the signs are going to change a little bit. So here it's positive, and that doesn't overpower a negative. So it's still going to be negative cosine of x times x cubed. And then our next one is minus, and we have a minus sign. So that's going to turn it into a plus. So plus sine of x times 3x squared. And our next one is positive, and they're both positive, so that will make a difference. Plus cosine of x times 6x. And here, both of our terms are positive, but as we multiply across, it has to be negative. So it's going to be negative 6 sine of x. And then we have our plus c, which I suppose is just 0. Multiplied by nothing, and the antiderivative of 0, I think that's what it is. So here is our, oh golly, what's going on there? Here is the evaluation of this integral using the tabular integration by parts, and you can see that this nasty thing probably would have taken 3 steps if you had done it normally by the integration by parts of dov.